So let us try to understand how to find out beam reactions in case of simply supported beam carrying uniformly distributed load as well as point load. As shown over here, from the right hand side support, we are having the point load of 2 kN which is acting on the beam, and throughout the beam there is a uniformly distributed load of 1.5 kN per meter that is acting. So this is the point load of 2 kN. These are the reactions at the support, and along with this it is having the uniformly distributed load of 1.5 kN per meter. The distance of this point load from the right hand support that is given is 2 meter, and the total span length that is given is 6 meter. So for this arrangement we have to find out what are the beam reactions which are there. Suppose this is A and this is B. These are the reactions are A and reactions are B, and this is the point C, suppose. Then we'll apply the conditions of equilibrium over here. So summation of forces in y direction is equal to 0. Upward forces will consider them as positive, whereas downward forces will consider them as negative. Now as shown over here, the reactions, they are acting in the upward direction. So RA plus RB, they are acting in the upward direction, minus the point load of 2 kN. Minus, now this uniformly distributed load of 1.5 is acting over the entire span length of 6 meters. So it is 1.5 into 6, and that is equal to 0. So therefore RA plus RB will be equal to, now transfer both these negative terms on the other side. So it is 2 plus 1.5 into 6. So therefore RA plus RB in this particular case will be equal to 2 plus 1.5 multiplied by 6, so that total value will be 11. Now call this as equation 1. Now we'll take summation of moments is equal to 0. We'll apply the another condition of equilibrium. Suppose clockwise moments, we consider them as positive, and anti-clockwise moments, we consider them as negative. Now we'll take moment about point A. So taking moments about point A, suppose. Now we'll start with this RB. This RB will produce anti-clockwise moment about A, and anti-clockwise moments we have considered them as negative. So it is minus RB, and the perpendicular distance from B to A is 6, plus this 20 kN, this 2 kN point load will produce the clockwise moment. So plus 2, and the perpendicular distance from this 2 up to this A will be 4 meter. So it is 2 into 4. Now this uniformly distributed load, the uniformly distributed load is of 1.5 kN per meter, and so for 1 meter it is 1.5, but it is acting over 6 meter length. So 1.5 into 6, that will be total UDL length, and it will be acting at the, that will be total UDL load, and that will be acting at the center of this 6 meter length. So this distance that we are considering, this is 3 meter. So this UDL we have converted into point load. So it is 1.5 into 6, that is the total UDL, and allow it to act at the center of 6 meter length, that is 3 meter. So this UDL, it will also produce the UDL load, that will also produce the clockwise moment. So it is 1.5 into 6, that is the total UDL load, and multiply it by 3. So that will be equal to 0, and therefore we can say that it is 2 into 4 plus 1.5 into 6 into 3, that will be equal to RB into 6. So therefore this is 8 plus, now we are having this 1.5 into 6 into 3, so that total will be 27, that is equal to 6 RB, and therefore 35 will be equal to 6 RB, or we can say that 35 divided by 6 is equal to reaction at B. So RB will be equal to 35 divided by 6, that is 5.83 kilonewton. Now we can substitute this value in equation 1 and we'll get the value of RA from it. So from equation 1 we can say that RA is nothing but equal to, it is 11 minus RB, so that is equal to 11 minus the value of RB just now we have calculated as 5.833, so it is 11 minus the given particular answer, so total will be 5.166 kilonewton. So this is our required answer. So in this way we can find out the beam reactions in case of simply supported beam.